Right, we need to do a bit of work on natural logarithms. Go back to logs again. So notation, ln x, that's ln, ln x is equal to log to the base e of x. And we're just going to focus on sketching first. So I want to sketch y equals ln x. And the base is e. And the power is y. So e to the y is equal to x. If I interchange x and y, that will give me my inverse function. And so swapping over my x's and y's, y is equal to e to the power of x. And so e to the x and ln x are inverses of each other. So we can sketch y equals ln x by reflecting y equals e to the power x in the line y equals x. So e to the power x is going to be 1, gets big quickly. And then if I draw in y equals x and reflect, then y equals ln x. I feel like I need another colour. What's that one? I'll use red. Right, so y equals ln x is going to go to be 1 on the positive x because I'm swapping over coordinates. The asymptote is going to go negative y instead of negative x. And then as this one gets steeper and steeper and steeper, this one here, the gradient will approach 0. And it will approach 0 quite quickly. It will never be 0. But because this is steep, this will come over relatively quickly. This is sometimes described as the slowest way to infinity. So if you imagine your y coordinate, it will approach infinity. There's no horizontal asymptote because the gradient is never, it's not approaching 0, it's still increasing the whole time. But as you move along, the increase becomes less and less and less. So you're going to go up that y-axis incredibly slowly. But that is the graph of y equals ln x. You could do the same for any logarithms. So if this was log to the base 10 of x, then that would be y equals 10 to the power of x. So it's, you know, the same thing will work to any base, but we're just doing this to base e at the moment. So just a little bit on sketching. So y equals ln x. We've got an asymptote there, and it comes up like this. If you want to sketch instead y equals ln of x minus 2, again you can use your transformations. So this will move ln x to the right by 2 because you're basically doing f of x minus 2. If you're not happy with that, the asymptote is where this bit in the bracket equals 0. So asymptote, because that's the first place where ln is undefined. You can't ln 0 or negative. So the first place it's undefined is where x minus 2 equals 0. And so x equals 2. But you know that from your transformations, so you can just pick it up and move it to the right by 2. And then you can just pick up your x-axis intercept and move it to the right by 2. So, you know, that's kind of quicker. But we also know that ln of 1 is equal to 0. So if y equals 0, we want ln x minus 2 to equal 0. And so x minus 2 will equal 1 and x will equal 3. So if you don't want to use transformations, that's the way to do it. So I'd say a good mixture of both is probably the ideal thing. So asymptote at 2, let's bring this down a little bit more, and through 3. And over. So it's the same idea as asymptote, shape, x-axis intercept. You may get a y-axis intercept if it's gone over, in which case to the left, in which case you can just let x equals 0 to find your y-axis intercept. I'll do one more. So we've got y equals ln of 5x. So that's a stretch scale factor 1/5 in the x-axis. And if you're happy with that, you can pretty much just draw it. But otherwise, the vertical asymptote, so to get the vertical asymptote, making up notation here. So 5x equals 0, x equals 0. So the asymptote is still on the y-axis. And to get the x-axis intercept, where y is 0, you want ln of 5x equals 0. Ln of 1 is 0, so you want 5x to equal 1 and x to equal 1/5. And so that's your stretch, scale factor 1/5, parallel to the x-axis. So the asymptote won't move for this one. Instead of going through 1, it's going to go through 1/5. You could draw exactly the same as this and just write in 1/5, because we haven't scaled the axes. There's no problem with that. And so that's coming up there and over, like that. So I'm kind of hoping, I think it's enough for now anyway. I'll find you some questions.